I'm John Rubenstein. I'm a scientist at the Hospital for Sick Children in Toronto, and I'm a professor at the University of Toronto in the departments of medical biophysics and biochemistry. For many of the problems that our collaborators are working on, Cryo-EM is the only method that will give them atomic resolution insight into the structures of the molecules that they're working on. So these projects range from people working on bacterial membrane protein complexes that could be involved in the formation of biofilms that lead to severe infections and difficult to treat infections, structures of things like coronavirus spike proteins. We've had some collaborations where we've helped out with those structural studies, and those of course are important for the development of new and improved vaccines, and also targets for mammalian proteins involved in cancer signaling, where the structures could give insight into how one might come up with a new therapeutic to treat cancer. And so we use Thermo Scientific Glacios 2 Cryo-EM to very quickly go through large numbers of specimens, collect small data sets from those specimens, first to figure out what needs to be done to optimize the specimens. And then once they've been optimized, we can transfer them to our ultimate microscope, Thermo Scientific Titan Krios microscope, for the final data collection. So the Glacios 2 has been extremely efficient in letting us screen specimens optimally and generate a constant stream of really high quality specimens that can go onto the final microscope, the Krios, and provide the publication quality data. So it was the missing piece to let us quickly generate lots of specimens that can lead to lots of publications, lots of biomedical insight, lots of grant funding, and lots of impact. It is an extremely exciting time to be in Cryo-EM. I think we've benefited a lot from the advances made by many members of the community pushing on areas such as specimen preparation, imaging methods, and image analysis. But none of this would have been possible without sustained effort from companies that have developed these great instruments, and particularly the great cameras that have revolutionized Cryo-EM and brought us from the blobology phase to the state of the art in structural biology.